A longer question on work and energy. A skydiver of mass 70 kilograms jumps from a stationary balloon and reaches a speed of 45 meters per second after falling a distance of 150 meters. Part A, calculate the skydiver's 1. Loss of gravitational potential energy and 2. Gain in kinetic energy. And this is where you can check the equations on your formula sheet. So loss of gravitational potential energy will be equal to mg delta h, and that's equal to 70 times 9.81 times 150, which equals 103,005 joules. And part 2, the gain in kinetic energy, we will need to use the equation here, which is half mv squared. So it's a half times 70 times 45 squared, which equals 70,875 joules. And you may have noticed there is a difference between the two values, and this isn't a simple case of just saying that the potential energy all transfers to kinetic energy. Remember, from a skydiver, there's going to be work done against air resistance as well. So part B, the difference between the loss of gravitational potential energy and the gain in kinetic energy is equal to the work done against air resistance. Use this fact to calculate 1, the work done against air resistance. So that's going to be the difference between the gravitational potential energy and the kinetic energy gained. So if we subtract those, we get 32,130 joule. And then part 2, the average force due to air resistance acting on the skydiver. And this is where we can use work done equals force times distance. We've just calculated the work done in part 1, and this is an example of where you very often have to use the value from the part 1 in the part 2. And so 32,130 is equal to F, which is our average force due to air resistance, multiplied by the distance, which is 150 meters, and that 150 meters was given at the beginning of the question. And then we can just rearrange that to get F equals 32130 divided by 150, and that's equal to 214 newtons. So that was 7 marks in total. How did you do? So we're now going to practice some questions on work and energy. Question here, the diagram shows part of a fairground ride with a carriage on rails. The carriage of mass 500 kilograms is travelling towards a slope inclined at 30 degrees to the horizontal. The carriage has a kinetic energy of 25 kilojoules at the bottom of the slope. The carriage comes to rest after travelling up the slope to a vertical height of 3.9 meters. Part 1 showed that the gravitational potential energy gained by the carriage is 19 kilojoule. And we can use our equation on the data sheet. Gravitational potential energy is equal to m times g times delta h. So it's mass times gravitational field strength multiplied by the change in the height, which equals 500 times 9.81 times 3.9, which equals 19,130 joule. Part 2, calculate the total work done against resistive forces as the carriage moves up the slope. And so from conservation of energy, the kinetic energy that the car had at the beginning is equal to the sum of the potential energy gained plus the work done against resistive forces. And so we can rearrange that. The work done is going to be equal to the kinetic energy minus the gravitational potential energy, and we have both of those values. So it's 25,000 joules for the kinetic minus 19,130 for the potential is going to equal 5.870 kilojoule. Now on to part 3. Calculate the magnitude of the resistive force acting against the carriage as it moves up the slope. And the first thing to do here is to use a little bit of trigonometry to find the length of the slope d. And we've got the opposite to the angle 30 there. The opposite is 3.9 meters, and we need to find the hypotenuse, labeled D. So we can use sine theta equals opposite over hypotenuse. So sine of 30 is equal to 3.9 over D. Rearrange that to get D. We get D equals 3.9 over sine 30, which is equal to 7.8 meters. We're then going to use that value of distance in the work done equals force times distance equation. We're trying to find the force F. So we've got the work done from our previous question. We need to make sure we use the value in joule and not kilojoule. So it's 5870 joule is equal to F times 7.8. So F equals 5870 divided by 7.8, which is equal to 753 newtons. We're now going to look at a further, longer, structured question on energy and work done. So a snowboarder slides down a slope, as shown in the diagram below. Between B and C, her acceleration is uniform. Part A, the snowboarder travels 1.5 meters from B to C in a time of 0.43 seconds, and her velocity down the slope at C is 5.0 meters per second. Calculate her velocity down the slope at B. So let's just see what we are given. We've got the distance there, 1.5 meters. We need to know the initial velocity u. We've got the final velocity at C, which we're told is 5 meters per second. And we're given the time as well, which is 0.43 seconds. And so we can use a SUVAT equation. S equals a half brackets u plus v times t. And so using that SUVAT equation, we get 1.5, which is equal to 5 plus u over 2 times 0.43. We can then divide through by 0.43, and we can multiply through by 2, and then we can subtract 5 from this side. So that will give us u is equal to 2 times 1.5 over 0.43, and then subtract 5 to get the answer, which is 2.0 meters per second. And so the marks here are for use of the correct SUVAT equation. S equals a half u plus v times time. It's for substitution of the values for the second mark, and it's for the final value for the third mark. B part 1, the combined mass of the snowboarder is 75 degrees, and the angle of the slope is 25 degrees. I'll just mark that on there. Calculate the component of the weight of the snowboarder and snowboard acting down the slope. And so we're trying to find W slope. We've got the hypotenuse, which is the weight. We want to find this one, which is W slope, and we know that there would be another component there as well, but we don't need that one. The angle theta is given. That's going to be 25 degrees, the same angle as the inclination of the slope. And so we can write sine theta is equal to opposite W slope over hypotenuse W. So W slope is equal to W sine theta. And so we need to find W from M times G. So it's going to be 75 times 9.81, and then multiply that by sine 25. So mg is 737 6 newtons, and so that's the weight, and so W sine theta is 736 sine 25, which equals 311 newtons. Part 2, at D, the snowboard has reached a constant velocity. She moves a distance of 2 meters at constant velocity between D and E. Calculate the work done against resistive forces as she moves from D to E. And so we know from Newton's first law, if a constant velocity has been reached, then that means that we have an example of equilibrium, where in this case the weight component acting down the slope is going to be exactly balanced by the frictional force. So we can say that the resistive force is actually also equal to 311 newtons. And then we can use work done equals force times distance, using that value for the force. So it's 311 multiplied by 2 meters is equal to 622 joule, or 620 joule to two significant figures. And then part C, the final part of this question, state and explain what happens to the gravitational potential energy lost between D and E. Right, so we need to structure our answer really well here for 3 marks. So we know that they are coming down the slope at a constant speed. So they are coming down, so the gravitational potential energy is still reducing. And that energy is being transferred into thermal energy. And that's because there is work done against friction or other frictional forces such as drag. We can also say that there's no further increase in kinetic energy. Okay, so first mark, the idea that the GPE is transferred into thermal energy. Second mark is for naming a correct resistive force such as friction, drag or air resistance. And the third mark is for saying that work is done against the friction, or for saying that there's no further increase in the kinetic energy. So well done if you managed to get 3 marks there. This is a conservation of energy exam question. So we've got a diagram there showing a water slide, and we can see that at the top of the slide, which is 32 meters above the bottom of the slide, the total distance along the slide is 120 meters. A person of weight 700 newtons, initially at rest at the top, slides down. His speed at the end of the slide is 15 meters per second. Part 1, calculate his energy at the end of the slide. So to do this, we first of all have to calculate the mass from his weight. So we know that W equals mg. We're given W, m is equal to W over g. So 700 divided by 9.81, and that gives 71.4 kilograms. We then put that value into the equation for kinetic energy, which is half mv squared, and so it's a half times 71.4 times 15 squared. That's the velocity value that we're given here at the bottom of the slope, and that gives us 8,000 or 8.0 times 10 to the power of 3 joule. Part 2, calculate the average resistive force acting on him as he travels down to the end of the slide. And so thinking about conservation of energy, we can calculate the potential energy that he had at the beginning. We can make that equal to the kinetic energy at the end of the slope plus the work done against the friction coming down the slope. So work done is equal to potential energy minus kinetic energy. Potential energy is found from weight times height, so 700 multiplied by 32. And then we'll subtract the kinetic energy value that we calculated previously, and that gives work done equal to 14,400 joules. And then work done is equal to force times distance. So force is work over distance, 1440 for the work, divided by the length of the slide there, which we were given as 120 meters, gives us 120 newtons for the final value of resistive force.